and today we're going to explore normal distribution in our lesson of statistics. So let's get started. So first we're going to look at the central limit theorem and what that really means. So what the central limit theorem says is that as your population size, so let's go ahead, write it out here. As your population size gets larger, then your distribution will start looking more like a normal distribution curve. Okay, so what that really means, as the population size gets larger, the distribution of the samples start to reflect normal distribution. And that really makes sense because all the outliers and the averages start to reflect the true distribution of characteristics or observations. So that's really it. So for instance, if we take a whole class of Niqua, then there's gonna be differences. But if we take Niqua Valley High School as a whole, then our curve will start to look more symmetrical and bell-shaped. And that leads us on to the next term, which is normal distribution. And that is what I just described, which is your curve looking perfectly straight, symmetric, and bell shaped, which is what normal distribution means. So if we go ahead and draw an axis for what our distribution would look like, let's go ahead and redraw our curve. Then it's going to look exactly like this. And as you can see, let me do it in a different color, that it is perfectly symmetric. Okay, and if we want, we can even draw that with a line. And it is bell curved, so it doesn't have any outliers, gaps, or any of those other types of things. And then we have a density curve. And what a density curve is, it's basically that the total area under the curve equals to 1, and that every point has a vertical height of 0 or greater. So let's go ahead and draw that. We can demonstrate it with this same thing. And you know what? We'll use this graph that we described above. So a density curve means that all of these values, the total values equal 1. And we also saw this type of scenario in probability, how all of your total observations and percentages equal 1. So in that way, it's really similar. And when I say all the total observations, I really mean the total areas underneath the curve. And let's go ahead, just highlight that. So all of these total areas, they equal 1. And of course, the outliers as well. And then we also see that every point has a vertical height of 0 or greater. So we can just assume what's that basically saying is that there are no negatives. Okay? Or you could write it as x, as in your total observations are greater than or equal to 0. So that's going to be our density curve. And now let's go ahead and go on to the empirical rule, which is for normal distribution, almost all data falls within these specific distributions. Now let's go ahead and see what these specific distributions really are. So I want to just go ahead and let's draw our whole axis. And then I want to go ahead, and this is, of course, assuming for our normal distribution bell curve. And now, if this is, let's go ahead and draw that again. if this is going to be our mean right here, and of course for normal distribution, we can see that the mean equals the mode, and which also equals the median. All right. And that's one of the characteristics of normal distribution, which we will get back to later. So what the empirical rule states is that for the normal distribution, the data falls within these three categories, which are, and I'm going to say label this M, and this can be implied that's a mean, median, and mode. And then that's going to be within one standard deviation. This is, and you know what? We can write in a different color for our second standard deviation. That's going to be in our second standard deviation. And then another color for our last third standard deviation. And if we're doing that, then we can make our mean then a different color. All right, so that's her mean. And I like to draw that bold line. So within the first standard deviation, which is, and I'm going to label this, the mean is always going to be 0. That's going to be -1. That's going to be 1. So within these two areas, and I like to go ahead and label it within one standard deviation, we're going to call that our the 68%. So 68% of your population will be within one standard deviation of the mean. Okay, and that's going to be again for those black lines. And then two standard deviations, so that's which is going to be 95% of your population will be within two standard deviations of your mean. And that is going to be your orange lines. And then our last one is going to be 3 standard deviations. So your population, 99.7% of your population will be within 3 standard deviations of your mean. And I know that sounds like a lot, but if you look at it, it really makes a lot of sense because you're going to have a lot of your observations within 3 standard deviations, which are these purple lines. And really, we're covering the whole area of the graph. So it makes sense to have 99.7% of your population within those areas. And then 2 standard deviations, of course, that's going to be -2, and that's going to be 2. That's going to be 95%. And then the last one's going to be 3 and -3. And then we assume that the mean is 0. So that's really the empirical rule. And to find it out, if they say which of the following populations is within one standard deviation, all we have to do is 68% of the population will be within one standard deviation. And then go ahead and just write that answer down. And then I said we were going to go back to our normal distribution characteristics, and those are pretty straightforward, and they really comply with just normal distribution. So let's go ahead and explore those. So my number 1 is going to be that the mean equals the mode, which equals the median. All right, so that's my number 1. And then over here, let's go ahead and use that. My number 2 observation will be that the graph is symmetrical about the mean. And then we can really see that because, as we said above, the normal distribution includes the symmetrical bell curve. And then number 3 would be the maximum of the graph is at the center. Okay? And next video, we will look at z-scores. So I hope you guys found this video helpful.